let's go then. Welcome along, everybody. Wonderful to have you join us for Canterbury Tech's online monthly event for June. Of course, much celebration. Hitting level 1 last night at midnight means this potentially be the last of the online-only events that we do for the meantime. Fingers crossed, everything going well. Let's stick with the plan, make sure we're doing all of our standard COVID hand washing and coffee into our arms and things, and not bring this thing back so we have to accelerate the levels again. We've got a couple of great speakers lined up for you tonight, and before that we've got a quick update from Canterbury Tech and a couple of quick pitches. First up though, a quick run through the protocol for this meeting. We've obviously done it at all of our online meetings, but I'll cover it off again as well. Your mics will be off by default. You can choose to have video on or off, that's up to you. We're going to drop you all out into breakout rooms for some informal networking and small groups a couple of times through the meeting. Please don't dominate the conversation. Everybody gets a go. No sexism, innuendo, bad language, or slurs of any kind will be tolerated. So in other words, simply just please be nice. We all are anyway, but just continue to be nice. If anyone has any concerns about conduct, please note the name and privately message Brent or Neil, or potentially myself, although I'm really bad at checking the messages. And we'll consider removing them from the meeting. You could ask questions of our speakers via chat. We may pose one or two depending on how we go for time. Brent will be monitoring the chat channel, so we'll come back to Brent for that later on. So let's hand over to Neil, who has a Canterbury Tech update for us. Neil.
Okay, hopefully I'm sharing something.
You are.
That's good. Well, here's what we're going to do. We've got 3 quick pitches. Debbie will kill me because I've sneaked another one in. Anyway, quick update from me, some quick pitches, and then get on with Adam, bit of networking, then Samantha. A warm welcome to our newest members. Yes, we have some. We were thinking we might lose a few, and maybe we will, but we've had some new ones join, and some of them will hopefully be on this call. So thanks to everyone for joining as members. Net Promoter Scores, we're always proud of these. We're still doing okay according to you guys. Let's see how we fare this month. And here's some upcoming events. Vision Week is on this week. Looks of interest. I haven't actually participated in it as yet, but it's sort of looking to the long-term future for New Zealand and trying to get some debate going around that. Tech Week, I'd certainly draw to your attention. We do want to get a few events up and running for Tech Week. It's been pretty quiet. It is online only. It's only a few weeks off now, so please consider running some kind of event during Tech Week. And we kicked off the first program for our mentor program last night. 16 mentors, 16 mentees. I think it was pretty well received. We've done the matching. Now it's handing over to those pairs to run 6 sessions over the next 12 weeks or thereabouts. And we have a second program this year, which we're calling Career Start. So the first one we kicked off last night is meant to be mid-career, people already embarked on their careers in tech. The second program is Career Start for those students, new immigrants to New Zealand, just about to embark on their career, and give them some pointers and maybe help make some connections for them locally. You may or may not have seen the Epic podcast. We're running this series of podcasts around the role of technology, really, in post-COVID world, trying to stimulate and raise the profile of the debate on that front. In my view, there's a lot happening within the tech sector, but not so much outside of the tech sector in the wider business community and with government. I'm sure there is some thinking going on, but we aim to be part of that debate. So far we have put out 3 episodes. There they are, a pair of bends and a rod. And we have one more episode about to go out with Paul Spain, and Andy and I have some time with Minister Woods, on Thursday of this week. So that would be our 5th episode. So please take a listen, join in the debate, social media, email us at podcast@canterburytech.nz. We'll get in touch some other way. And that's actually pretty much it as far as the Canterbury Tech update goes, although we just concluded a committee meeting where we decided on a clearer direction for the Tech Summit this year. We will still be running one. There will be opportunities to participate both in person and online. So look out for a further communication about that in the near future. I don't really want to give away too much more at the moment. And bear with me. Kelly.
Hi.
Are you there, Kelly?
I am. Is everything working? Can you hear me?
I can. Hopefully everyone else can as well, but they're all muted, so they can't say anything. So let's assume they can hear
you. Cool. So, hi everyone. Many of you will hold insurance policies currently, so I'd like to talk to you about the importance of having the right insurance advice. I've spent a number of years working with various tech companies, learning about your industry and understanding how the insurance products that are available to you guys will respond in the event of a claim. Traditionally, many companies providing IT services will have a professional indemnity policy, which gives cover in regards to the services you offer. However, this policy won't respond to a civil claim as a result of a product failure, such as any software products that you've recommended, installed, or used to provide your service, nor will it respond to the Privacy Act breach. Companies are hurting now more than ever, and people are really quick to turn to lawyers when something goes wrong, especially when they've been financially impacted. We've seen a major increase in claims in the last few years, as well as settlement figures. A couple of web hosting companies have lost clients' data, and they've had claims between $12,500 to $85,000. Even at the lower end of the settlement scale, this cost can be devastating for a company. The current Privacy Act is still being reviewed by Parliament, and if reform goes ahead as expected, companies will be obligated to advise of any breaches, and this will impact on them directly in regards to fines, lost revenue, public relations, and legal costs. I won't begin to lecture to you guys about cyber security, but it's important to remember that nothing is infallible, and often these hacks are a result of human error. You can insure against the lost revenue following a hack, and this could be revenue lost due to the time used to reinstate data for clients or rebuilding any programming that you're working on. Any international work you carry out is also subject to international privacy law, such as the UK's GDPR, and I can assure you that the alleged privacy breaches are being investigated thoroughly with court cases pending. Another key point to remember is that cloud hosting companies do not accept any liability for hacks, so your clients will look to you to make good any losses that they suffer from this kind of event. IT and cyber liability policies are specialised products and they're not available via the direct insurers, and not all policies offer the same level of cover. So it's worth getting in touch with me to have a chat about your business and whether your insurance policies will work for you when you need them to. Thanks everyone, and sorry for the voice. I've obviously been talking far too much today. That's me.
Thank you, Kelly. Next up, we have Sasha.
I've got my own slide. Debbie thought that would be easier. Is that okay for me to just screen share that?
Yep, go for it.
It's just because it's got a silent video in there. Is that everyone can see that? Hopefully. Great. So hi everyone, my name is Sasha McGregor and I run a company called Follow My Lead, and what I do is make tailor-made video software tutorials. So I've got a short video here that will just play in the background, which will give you a bit of an example of what it will look like if it's going to play. Here we are. So it'll just run in the background. So basically, yeah, that's what I do, is make video software tutorials. So I work with businesses and also with software developers to teach users how to use their systems. I work with them to determine best practice. We then break down the processes into a series of simple steps, create a script and a storyboard for that. And then with the use of screen capture, voiceover, motion graphics, and video editing, I create video tutorials to teach their users how to use the system. So I think the thing that I love about video tutorials is that they're available anywhere, anytime. And I think the importance of that has become very apparent with COVID in the last couple of months. You know, all you really need to be is at home with a computer and you can learn how to use the system. You don't need somebody sitting next to you. They're accurate because I work with the business or the developer to determine best practice first, so you can be sure that whatever you're showing people in the video is the correct way of doing something, and your next door neighbor hasn't said, oh yeah, just click this, and it turns out that that's wrong, and then you teach that to someone else. And I think the last thing is that they're easy to follow. I've spent a number of years working, especially in media and both TV and radio. Spent a long time taking a big concept and trying to turn it into something simple and easy to follow. So that's the other side of it that comes into play there for me. So please feel free to connect with me on LinkedIn if anybody wants to. You can find me under Sasha McGregor. My website is followmylead.co.nz and my contact details are there.
Thank you. If you want to unshare.
Or, here we go, or yours.
And last but not least, the legendary Martin Rivet.
Thank you, Neil. Thank you for fitting me in at the last minute. So I'm very pleased to let you know that we've just released the Horizons 2020 report looking at trends in technology education. It's a free and Creative Commons piece of research that you can steal and use to your heart's content. And there's a range of analysis and research on technology ed. So looking specifically at professional and graduate education, so I hope relevant to many of you, and considering the industry perspective and perspectives for learners and the academic institutions. We've reviewed a range of national and international sources, and we have some original research of our own. So that's available for you now. The link I'll post in the comments in a moment. And we'll also be hosting a panel discussion on the 18th of June from 4. I've got some international education futures expertise from the States joining us, some very interesting perspectives from industry, and I hope to pad that out with some more exciting people. Yeah, those links will be in the comments shortly. So thanks for my moment.
Thanks, Martin. And I've had a sneak peek at this, got to review an early copy of it, and it's a very worthwhile piece of work. So it's worth taking a look at. Please do.
Much appreciated, Neil. Thank you.
So to move on, and I'm going to hand back to Andy.
All right. So we're getting into the first of our two presentations for this evening. And our first presenter is Adam Lyness. Adam co-founded Intranel in 2005. Intranel provides industry-leading business and development teams so you can accelerate technology delivery. They'll help you to implement lean, fast, cost-effective development, leveraging new technologies, and build genuine agile capability. Welcome, Adam. Great to have you with us at Canterbury Tech.
Thanks, Andy. Appreciate it. So if I can just start sharing my screen here, we can dive into it. And so let's share that one.
So you've got something to tell us about AI in road safety that you've been working on with Intranel.
That's the one, yes. So this is an area we've been exploring for quite a while. So we've always had an interest in emerging tech, and exploring that and building a whole bunch of devices to identify and track objects. We ended up doing a bit of brainstorming to figure out where the major applications were going to be in this area, and we felt certainly in the New Zealand context that road safety was going to be important there.
So this could be a killer app so to speak.
Yeah, I tried to avoid using that particular phrase, but there you go. You've
I
you've
liked
said
it.
it
I had
now.
to throw it in there.
Yeah.
All right. And just before we get into your presentation, I've got one last question for you. You mentioned to me earlier that during lockdown, you had time to work on a personal project as well. Tell us a little bit about that, because I thought that was intriguing.
Oh, that's so just as that's a real side project. So yeah, I had, lockdown gave me an amazing example, an amazing opportunity just to be able to focus on my side project, which in this case was an ultralight portable hiking shower. So it's the only gas shower in the world that you can fit in a tramping pack. It only weighs about just over a kilogram. So if you want to check that out, go and have a look at wildafresh.com. Fair warning though, if you explore that site, you may see my butt in one of the pictures. So just be aware of that.
Lovely. And that's a good example of what people have been able to use with productivity through this lockdown period. As well as doing your day job, you've had some time to be able to invest it into something. And that's a product that potentially might not have come to market if it hadn't been for the COVID lockdown. So I find that quite interesting. You're doing it as well as helping other people to do it.
Yeah, well, there is an element, particularly like a lot of businesses, you saw, especially some of those larger projects deferred, and so it's freed us up to do some different things and to work on the business as well. And to some extent, that's driving some of this AI exploration too, right? Just having some time to explore that.
All right, well, let's have a look at what you've been doing within the road safety area with AI.
Rightio, I'll crack into it. So I've already done the intros, and as we mentioned, we've just had a recent focus on exploring and building our AI capability. That's mostly been around computer vision applications, so developing tools to recognize and track pretty much any object. And we've been using hardware like Google's Coral Accelerator. This again led to conversations about where in the New Zealand context this would have the biggest impact. And from our internal to and fro, it's really road safety that came out on top there. So today I'm going to make an argument that an affordable, effective, and not only that, politically tenable AI-driven road safety system is viable and could save lives and reduce serious injuries. This requires expanding our view of road safety maybe beyond just physical infrastructure and incorporating more high tech in that mix. That said, I think still where the technology sits, this is now an engineering challenge with manageable, quantifiable risks. It's no longer just blue sky research. And that means that right now we've got cheap, proven AI and IoT technologies that could provide major short-term harm reductions. And on that, I'll outline a system later that could cost effectively be retrofitted to our road network and vehicle fleet. So of course at stake here we have human lives, and the road toll in New Zealand's remained fairly static despite many campaigns around driver behaviour. These are expensive and they're slow to shift the needle because the major underlying factors we're dealing with is human fallibility. So, anecdotally, when I talk to friends, or just with my own experience, just about everyone admits to having made a mistake on the road that could have seriously hurt someone else when driving. And the social cost of this is huge. So, they estimate roughly 4 billion and 4.8 billion in 2017, and that's across 378 fatalities and 3,000 serious injuries. And when we look at fatality rates, New Zealand fares fairly poorly, even comparing to Australia's 5 deaths per 100,000 of population. We're coming in well down the OECD table at about 7.9. And these higher accident rates, I think, are driven by New Zealand's high-risk roads, our extensive network of just 2-lane highways without the centre barriers and our older vehicle fleet. On the other hand, this does make a stronger case for AI-based safety infrastructure. It's got the potential to be more effective here and potentially a lot more cost-effective than physical infrastructure.
Adam,
yes.
Have you got slides there? Because we're not seeing them.
You're not seeing them?
Yep.
Okay. So
I've got to hit the share screen button. I've just
we've
realised.
Yeah, we've got that going. let's have a look here. Hang on, I'll back out. I may
Just
have
click
to.
share screen and Zoom.
Yep. So share screen. Let me just try that again. There we go. It might. Are we working now?
We've got.
Screen sharing. Yep. There we go.
Like Teams.
Yep. Let's bring up that presentation again, which is the.
There we go. Good work. Thanks. Leave it to you.
There we go. So, what screen am I sharing? I'll just flip those around. One more time. Display settings. And yeah, how's that looking? You've got the full screen there?
Yep, working good.
That's good, Adam.
Cool. There we go. So we're just on this slide with the looking at the road toll, and then keep comparing where we're sitting in the OECD. So really, that's just adding a few visuals to what I was talking about there before. So moving on, why use AI for road safety? Well, we think it's vital for a distributed safety network, because on a fundamental level, what you need to know is the location and velocity of moving objects on the road, as well as the topology of the road itself. And it turns out that the latest generation of AI devices are really, really good at tracking multiple objects reliably and cheaply on low-cost, low-power hardware, and they don't need a cloud connection. So if you can communicate that data to a in-vehicle user interface, you can assess risks and provide users advance warning to avoid accidents before they happen. And we've been playing around with computer vision probably since the early 2000s, and a lot of the earlier techniques struggled with variations in lighting, orientation, and background, but the current algorithms and hardware are vastly better. And what these enable is plug-and-play nodes to be added to a network where required. You don't need complex tuning. So AI can also be used by in-vehicle modules to detect maybe a sleepy or distracted driver, and both these are major causes of accidents. And again, it's no longer a major technical stretch. It can run on cheap hardware and providing older vehicles with many of the key safety benefits of newer, higher-end vehicles. We're also seeing convergence of other tech playing a part in this, including IoT, solar, and battery, and better communications tech. So all of these are mature enough that implementation and deployment risks are actually well understood. So here's a screen grab from a project we did to track and differentiate different brands of scooters. In this case, it's a Lime and a Flamingo, running on about $200 worth of hardware. So that's just a Raspberry Pi and a Google Coral Inference Engine, and that'll run at real-time video rates. So training the model to recognize scooter brands just took a few hours and about $40 in my credit card to actually hire the damn things. This one's an open source tracking project, so it's demonstrating pretty solid performance in a very complex scene. It's also a good example of AI not being infallible. If we have a look at the image of the person detected on the bus there, circled in yellow, so as far as the AI is concerned, that's actually a person stuck to the back of a bus. AI is currently unable to take account of broader context in a scene in the way a human brain does. And this is one of the reasons why it's really difficult to make bulletproof autonomous vehicle systems, something I'll touch on next. So in talking about a road safety network, it does raise the question of why we need smarter roads if we can just wait for smarter cars. If we're talking fully autonomous vehicles, the challenge is we may be waiting 30 years in New Zealand before the technology becomes ubiquitous and the existing fleet's replaced. And that's going to equate to maybe 10,000 deaths and hundreds of thousands of serious injuries. And another problem is that reliable autonomous vehicles are orders of magnitude more difficult to achieve than a supplementary safety system, as the acceptable failure rate's close to zero. Most of us, we're just not going to embrace computers that occasionally glitch and kill us. A supplementary safety system doesn't need to be right all the time to deliver it on its core purpose. And in fact, it may even be better to not be always on to prevent some over-reliance or complacency when users are driving. If we're talking in-vehicle AI-based safety features, these are already saving lives in newer vehicles. And to me, this strengthens the argument about retrofitting some of these into our existing fleet. In-vehicle systems aren't the only answer, of course, as they have the downside. They can't see around corners or pick up potential hazards further than 100 or so meters away. So a safety network that tracks everything on the road is also highly complementary to autonomous vehicle technology. So it's going to provide an additional reference point in terms of positioning to combine with other sensor data, and that's going to boost both safety and reliability. The government's current view in this, from talking to people in the transport sector, seems to be to leave the high-tech side of things to vehicle manufacturers. But we believe that government, as the major funder of infrastructure, does have a role to play in collaborating on high-tech roading infrastructure and developing protocols and standards around this. So delving into a little bit of technical detail, here's a basic topology of how we think an automated road safety system could be structured. So that the focus here is still very much on safety rather than automation or traffic management, but it would complement those functions strongly too. So the core of the system is based around roadside tracking nodes that know their location in relation to the road and can collaboratively track location and velocity of vehicles or pedestrians within visual range. So if we zoom into the roadside node here, you've got familiar tech, your road cam, an AI engine, GPS module, mesh Wi-Fi connection, and a couple of redundant powered Ethernet connections to 2 separate base stations. The roadside nodes also work together to hand over tracking vectors for individual vehicles to get better location and velocity estimates and minimize the effects of occlusion from other vehicles. We've got base stations down here, spaced about every kilometre, to provide a power of 500-metre string of 10 roadside nodes in either direction. And they can draw power from either the grid or a solar battery combination. Cloud connectivity could be through 4G, LoRa, IoT, trunked radio, or even satellite internet. So that connection can be low bandwidth, given image processing is occurring just in your local hardware. The in-vehicle module here, it's going to receive data from the road network on road topology and vehicle trajectories, and it's going to calculate potential risks to the driver. So if these exceed a threshold, there are several tiers of audio and visual alerts depending on the risk level. And that vehicle module can also act as a black box recorder. So you've got accelerometers, road and driver facing cameras also generating alerts around fatigue or distraction. And all these nodes can be redundant. They'll self-adapt to their location, which means a roading crew, if something goes wrong, they can just drop in a replacement as easy as they would, say, a reflector post. All right, so I guess it begs the question, if we've got a road safety network in place, how does it actually reduce accidents? The AI's job is to give drivers advance warning of hazards, whether or not these originate from the driver's behaviour or another vehicle. So if we look at primary accident factors on the right of the table, intuitively it's not difficult to see how this could save lives when we compare them with detectable events on the left of the table. So those crash factors on the right make up a key causative factor in the vast majority of serious accidents, and this is data that's pulled directly from NZTA's crash accident system. So anyone can access this online. This is data for Christchurch. You can see every one of those dots represents an accident of varying severity, and you can zoom in and find a whole bunch of data, including causative factors. Heuristics around risk alerts can be fairly simple. For instance, if you're pulling out to overtake and there's an oncoming vehicle, you'll get a warning. Metrics around what constitutes, say, dangerous driving are more complex, and that would involve a combination of maybe ambient conditions, speed and acceleration, whether a vehicle's crossing the centre line. And one of the other advantages is that safety measures in a network system can be micro-targeted to a particular area. So for instance, if an accident's blocked a road, or if police have initiated a pursuit of a dangerous driver, you could warn other drivers in the vicinity. Any safety warning system, of course, we recognise comes with behavioural challenges. So if users feel overwhelmed with unnecessary warnings, they're going to get sick of them and pull the plug. So think about maybe that annoying beeping in Japanese imports if you travelled over 100 and 10 k's an hour, which pretty much everyone I know disconnected within a few weeks. AI has an advantage here in that it's able to adapt to risks and prioritize them. So as an example, if it knows you drive up to intersections at a great rate before slamming on the anchors, it can adapt to that. So it's only warning you at appropriate occasions. So looking at value of data in this type of system, a huge benefit of a tracking network is that even on a small scale, it's going to give us super accurate data on accidents. And even probably more importantly, near misses. And currently, these get missed, but they probably outnumber accidents 10 to 1. So driving behavior that generates actual accidents or near misses can be fed back into AI models to improve these as well. When we build better risk models, we can enable better targeting of risky behaviors. And this targeting can be much more nuanced than what we currently have, say instantaneous speed cameras, and it doesn't have to resolve around punishment. So a good example perhaps of that is that eRoad, which is a New Zealand business, is already producing devices that provide feedback to professional drivers. And anecdotally, this is leading to self-correction and safer driving practices. Yeah, privacy concerns are always going to be raised around any kind of network that tracks stuff. I'd argue that driving is a privilege and drivers don't necessarily have a right for their behaviour to be outside the purview of the state. And I think there's at least tacit acceptance of this with wide deployment of enforcement measures and traffic cameras that can already track vehicles around central city areas. Another element of protection is that AI happens on local nodes and video data isn't routinely sent to a central server. So from a privacy perspective, there's a huge difference in, say, hoovering up every license plate and sending it to a server versus local roadside nodes receiving a list of stolen vehicle plates to look for. So they're just focused purely on that. Video data would only be centralized in the event of an accident, as would in-vehicle module data. And to me, that's fairly similar to the situation now with drivers installing cameras for their own peace of mind. So politically, we don't see more advanced road safety systems causing major public backlash, particularly if those initiatives are community-led and the core focus on saving lives is maintained. Around uptake, we'd see these kind of advanced safety systems having initial appeal maybe to within the insurance industry. You can see parents of young drivers being keen and potentially regular commuters on known dangerous routes. So in terms of government role, it's difficult to tell at this stage really where there are, although anecdotally it seems mentions of high-tech roading solutions have actually reduced in recent years. This is a pity because we think there's a role for government to fund non-physical infrastructure and collaborate around innovation and potentially development of standards. Right, that's pretty much it for my blah blah bit. We think AI-driven road safety networks are worth exploring independently in New Zealand, as opposed to waiting for other countries, because we're particularly well placed to benefit, and everyone else is distracted building autonomous vehicles. All the core technologies to build an effective network are mature enough that the problem is an engineering one with manageable risks rather than blue sky research. At this stage, we're really just exploring the ideas, having a number of conversations with both tech and roading infrastructure transport people. So I'd be interested to hear your thoughts on whether it's worth pursuing, as well as anything I've got wrong or missed, or any connections or people I should be talking to. So thanks for listening, and I'll hand back to Andy.
Thanks, Adam. Hey, just curious, what happens if you've got two people using a vehicle and one's got a lead foot and one doesn't?
I think the learning is actually tied to recognizing through that driver-facing camera, it's actually going to recognize the driver. So without you having to sign in or do anything, it'll know it's you. And again, a lot of these problems, particularly if you don't have say 3,000 drivers driving the same vehicle, it's not a difficult problem to identify and differentiate drivers pretty accurately.
Nice. Now we've got time for a couple of quick questions, and I see there's a couple there that have been submitted. Neil. No, Brent.
I've got the questions up here. Yep. Vaughan wants to know if it could be used in reverse. For example, if you're driving at night, can you use the AI to prove that the road is clear so you can go crazy?
Yeah, that's one of the challenges that you actually have to overcome, like an absence of warning being a green light to do something reckless. And so, you've got two defenses against that. Partly is you don't necessarily give someone an always-on solution. The second one is that there's a little bit of an element of Big Brother watching. So if you're installing the system, you're taking accountability for your driving. And if you do something reckless, it can be recorded by the network and reported.
Also from Vaughan, what's the projected, oh, hang on, it all changed. What's the projected cost per kilometre to deploy?
We haven't done those numbers, and the reason is it would be highly speculative. But, when we talk about it not being blue sky research, this would be a problem. Where you'd build you could build a prototype system over maybe 10 kilometres of dangerous road. It's going to be in the millions. Whether or not it's 2 million or 10 million, you'd have to break the numbers down, but it's probably going to be less than the physical realignment of one section of major highway.
Stuart wants to know, what if all cars had 1 to 2 centimetre positioning accuracy? Would that help the underlying goal of safer roads?
Yeah, absolutely. And there's other conversations in this space talking about inter-vehicle networks of building protocols that don't require roadside infrastructure. So vehicles are actually communicating their positioning and data with each other. Again, with similar objectives. One advantage with bringing in some roadside infrastructure is you're not reliant just on the systems within the vehicle, whether that be GPS or something else, and you've got a second point of reference with the roadside cameras, cross-referencing the vehicle's own idea of its position and velocity. So to some extent, these are all potentially complementary technologies.
Chloe has asked, I think the storage of data could be a privacy issue. How long is the data stored and who can access it?
Well, I don't think the network needs to know any data aside from the positioning of vehicles in your immediate vicinity. The only exception is when there's actually an incident, either an accident or potentially really dangerous driving. So, if people are going to, if you're going to sign up to this network, the network would warn other drivers if it detects that you're driving recklessly, warn other drivers in the vicinity. Potentially, it could record video of that driving, and that video could be passed on. I don't think this is a privacy issue any more than existing road safety mechanisms are. So the only information that actually ends up on a server is when there's been an incident. And I guess one of the challenges with these systems is there is an element of oversight and trust that goes into that, because any system obviously has the potential to be misused, or that data to be misused and sent somewhere it shouldn't.
Yeah, there was a comment there from Virginia saying that there was a court case a few years ago where a speeding driver tried to argue that the speed camera was breaching their privacy. Not surprisingly, the court said if you're on a public road, you had no reasonable expectation of privacy.
Yeah, which is kind of my view on this. But obviously, I mean, anything you implement has to be done with strong support on the you're going to have public buy-in. So I think it's a conversation that you have to be fairly open and handle carefully.
Yep. Colin has asked, how do you stop the driver relying on the system when it does not meet the reliability level for functional safety?
Well, we touched on that briefly before, and so again, I come back to, I'd say you don't have all segments of road covered. You may not even have it switched on all the time, and I think sort of building in that level of AI learning. So in other words, if you're coming up to an intersection, most of the time it's not going to do anything. So it's going to learn how you would normally recognize an intersection and decelerate. So it's only if you deviate that from a significant amount, say you haven't seen the give way sign, you're not slowing, and and it's becoming dangerous, only then does it step in. So, we're trying to avoid holding a driver's hand as much as possible and only giving a warning at the time where it's essential.
Graham wants to know, how well can it be deployed to rental vehicles?
Well, that could be a good starting point for a prototype. I've had a few conversations where people would quite like to get these on all the rental vehicles that get hired in Queenstown and immediately driven over the Crown Range. So there's certainly a few areas where it makes sense, but maybe not at the moment when there's very few tourists around, but certainly over time.
G has asked, will you use multi-agent to support the vehicle behaviour optimization?
That's probably a more technical conversation than what we've actually gone into at the moment. A lot of what we've done is really looking at the sort of pretty high level network basis, but also drawing on our fairly deep knowledge of fundamental computer vision applications and using AI in that space. So, in answer to that question, probably.
Mm-hmm. That was gone again. Sean has asked, the roadside infrastructure would be expensive. How much could you do with just in-car computing?
Arguably, you could end up, if you're talking about advanced in-car systems, so multiple camera deployments and radar systems and so on, you could end up spending more across your vehicle fleet with in-car solutions for a worse result than if you invested the money in roading infrastructure. So ultimately, I'd be speculating if I was looking at the costs there, but my view is that there's a role for both of them. And I certainly believe, even if we're not building roadside infrastructure, that in-vehicle black box recorders are probably going to start to have a more significant role fairly soon.
All right, just two more. This is from Graham. The wireless technologies suggested are generic and have various issues for such applications. Have you considered DSRC and or 5G based cellular technologies? This would decrease latency and provide much more robust, trustworthy communication.
Yeah, it's probably a fair point, and I'd say if as far as reliability goes, if you're going to have distributed, I guess 5G nodes in there, it's potentially a more expensive technology than Wi-Fi mesh networks. But again, it's something you need to look at carefully when you're comparing costs. But yeah, absolutely, I take the point. 5G is probably a more suitable technology for something like this.
And then the last question from Pat: will the knowledge about how drivers approach different road rules be shared between vehicles?
I see that more as feeding into training the risk models for the network. So then what we want to do is collect anonymized data so we can look at driving behaviors that actually lead up to near misses or accidents and use those for the system to train its concept of what constitutes risky behavior. That lets you both warn other drivers or provide drivers with feedback in advance to help modify their own behaviors. I guess in effect, because all vehicles receive the updated models and the network's running off the updated models, then that data is shared, albeit anonymously.
Very good. And not a question, but Grant English has reached out. So I'll leave you to catch up on a private chat after this.
Yeah, sounds good.
And if someone does want to get in touch, Adam, what's the best way to contact you?
Probably just my email. So adam@intranel.com.
Easy. Nicely done. All right. Now we're going to do what Canterbury Tech Meetings, one of our key things that a lot of people look forward to, which is networking. So Brent is now going to try and work out how the breakout rooms function works for the first time. Let's see how this goes.
Neil and I are messing with you, Andy. I've handed control of the breakout rooms back to him. So,
Okay, keep me on my toes. All right, so we're going to use Zoom breakout rooms and chuck you into a virtual room for 10 minutes for a conversation with a few random strangers or potentially people that you know from our sector. So Neil's going to unmute you all, and when time's up, you'll see a 60-second countdown and then you'll be returned to here, the main room. Neil, when you're ready.
Before that, I think I've unmuted you all, so just a quick round of applause, whoop whoop, or whatever you'd like for Adam. Thank you for.
Nice one, Adam.
Thank you.
And now I'm going to chuck you into breakout rooms for a slightly shorter period as time is getting on a little. Go.
Yeah, 2 copies of my face, it's weird.
One is weird enough.
Exactly.
Breakout room 14.
Welcome back. Let's continue with our second speaker of the evening. And she is from Arcanum IT. They build enterprise artificial intelligence solutions, and having spent the last 4 years building cutting-edge custom artificial intelligence solutions, the company has spent 12 months building proprietary tools that accelerate AI outcomes. Samantha, who's joining us tonight, is a data scientist who's been operating in the AI and machine learning industry for around 2 years in New Zealand. She was also involved for over 5 years in consulting and implementing more than 200 IT projects for government agencies and the private sector in Iran before moving to New Zealand. Welcome, Samantha. Lovely to have you with us this evening.
Thank you. Thank you for giving me the.
Now, I'm curious, what was it that got you interested in working with AI after running IT projects?
Yes, like to be honest, I got to the point, yeah, as you mentioned that I was in the software development, and that time back to like 10 years ago, working on .NET projects, CMS portal and website, and then I got to the point that I wanted more. So I decided I learned about, like in that time I learned about, I've heard about business intelligence, and I was so curious to learn more, and I know that yeah, maybe like doing some graduate studies could help me to build the background. Then yeah, then I started my master degree, and then in master degree I got to know about text mining and data mining, and was more interested in this field. Started to do a PhD. Came to New Zealand, and yes, I started my PhD at Vic Uni with the field of with the focus of machine learning and evolutionary computation, and I quite enjoy.
And got into Arcanum then.
Yes,
now,
thank you.
And you're based in Wellington and normally work out of Arcanum's office there. How did you find work during the lockdown?
To be honest, like the first few days, it was a little bit difficult to get used to the new environment. But then I just decided to enjoy. So like I found actually like myself more productive. Found that and the reason was that there is no unnecessary commute, and the meetings are short and just efficient and effective enough. Like finding my colleagues was much easier. And yes, like I quite enjoy and found a lot of free time, and I was like the first few weeks I was like watching a lot of movies, and I said, oh, actually I should have been more productive and like get the most from. So I started like doing a lot of self-development, learning a lot of different things, and I always wanted to have free time to learn. So at the end, like I really enjoyed. That was a really good experience to know that like in this industry, you are able to work remotely but still be productive. That was really good outcome for me.
And I think what we're going to see, one of the things from the people I'm talking to, is people are restructuring the way that they're going to work moving forward, that they might spend, you know, a couple of days a week or a couple of days a month or a week a month maybe working from their home offices because everyone's set up to do it now. And as you say, you know, you can become that much more productive. You have that extra time. Everyone's on time for a meeting. That's pretty cool. There are definitely some perks there. Now, you've prepared a little bit of a presentation for us on some of the work that you guys have been doing. Feel free to share your screen and take it away.
Awesome, thank you. Okay, let me share my screen with you.
Looking good. All yours.
Okay. Yeah, my screen is visible, right? Awesome. Okay. So today, I would like to first we are working on computer vision projects, and so today I would like to explain a little bit about those computer vision projects that we've been working on, and I mainly focus on object detection and object tracking. And then we'll introduce you 3 use cases that we have used. We have applied these 2 tasks on them. So let's see. I will give you some definition of what computer vision is. Probably most of you know, but let's have a quick review. So computer vision aims to enable computers to understand what is being seen in an image. It focuses on the problem of helping computers to see. And there are a lot of computer vision tasks, such as object classification, object identification, object verification. But today, I would like to focus on object detection and object tracking and show you how we have applied them on real-world problems. And first, let me to give you some definition of what object detection means, which is a common computer vision problem which deals with identifying and locating objects of certain classes in the image. And interpreting the location of the object can be done by creating a bounding box around the object. Now, taking an initial set of detected objects, creating a unique ID for each of them, and then tracking each of the objects as they move around frames in video while maintaining the assignment of unique IDs is called object tracking. So these 2 are similar. However, object detection can occur on still photos, while object tracking is a video feed. And as our use cases were limited to identifying people, we focus on person detection and person tracking. I need to note that tracking people is not a privacy issue. We're not looking to find specific people. We're looking at the movement of people through the space, not who is this individual and try to identify them over the camera. This is an anonymous people tracking and people movement. Now, in the rest of this presentation, you will actually see how we build out people tracking technology with the project that we did with All Blacks, and at the same technology can be applied to many different scenarios. So Playing the Gray is an AI-powered sport analytics platform that ingests video footages and processes it to produce sport analytics and insight. The platform uses player detection, player tracking, homography, position estimation, and with the help of statistical modeling, provides sports insight to a dashboard that can be easily communicated to coaches and players. All right. As here we discuss about real projects, let's watch a demo of this platform to see the features and the capabilities.
Revolutionary system for data capture includes both on-the-ball and off-the-ball assessment of how players are interacting with each other. Our system starts with machine vision, which identifies players on the field and generates XY coordinate data. The panel view on the upper right can be rotated and tilted to provide new perspectives of player formations. A 3D map can be...
Sam, we can't really hear the audio on that. I think you might need to select send computer audio on share screen.
Is it okay now? Sport. Here, we use the spotlight feature to highlight a player of interest. By selecting an individual, we can observe their path before and after the current frame. We can also show the speed of the player. Here, we are observing the path and speed of the England's first 5'8", Owen Farrell, as he runs in support of the ball carrier. As we watch the support run in slow motion, we see Farrell hit a top speed of 36 kilometers per hour, followed by rapid deceleration. multiple players can be selected to create a new perspective of team performance. This is achieved by joining these players together as a group. The distance between these players can then be shown. The speed of the players can also be shown when they are joined together, enabling line speed to be truly measured. The functionality of selecting multiple players can be extended further to put the selected players together into a pod. The distance between and across the pod, as well as the speeds of the players within that pod, can also be shown. Here we are, watching in slow motion the Welsh defenders close to the ruck. Based on player movement and interaction, events can automatically be detected and classified. Key moments are automatically detected from these events. The ball is also tracked automatically based on player interactions. With all this new data, we validate that pattern of play by watching the South African attack with high-speed footage. Here we see the South Africans work left to right before heading back to the midfield, from where they continue their attack, working to the right. The tactical use of space is assessed using the space map feature. Using this perspective, gaps and overlaps can be readily identified. Here, the South African first receiver exploits the game between the first and second Argentine defenders. Play in the Grey provides an unparalleled platform with access to tools that enable.
Right. So actually, All Blacks use the data to prepare for set pieces during the World Cup. Unfortunately, due to COVID, the plans for use with Super Rugby have been postponed. And we are now working with American football, soccer, and rugby league teams, and we've done work with racket sport, and the same technology can be applied to many different scenarios. So now in the rest, you will see that from the capability build, how we were able to translate from outdoor sport technology to indoor retail product. The problem that many retail and commercial companies have is that they often use expensive and ineffective methods to understand the usage of their spaces. The method they employ generally consists of Bluetooth devices, manual labor to acquire data, or they have security cameras that need human to watch them 24/7. But our solution is that big data, machine learning, AI, and computer vision can be applied to generate insights on how the space is used. This can unlock data-driven discussion for lease negotiation, space design, marketing, and compliance by using people tracking technology effectively. You know where and how long people stay in shopping center. Therefore, mall owners can increase the revenue by optimizing the tenants mix, and all the retail stores can increase the quality and quantity of the sales opportunity. So now let's have a look at a sample video footage and see that how we have applied our people detection and people tracking modules to generate some useful insights for retail analytics. This is the video footage recorded on level 4 of the PwC Tower in Auckland. Let's see that what we are capturing. As you can see in front of the cafe, the blue square representing dwell time. If people are there for more than 5 seconds, it starts counting. At the entrance doors, there are yellow lines. It counts when someone walks through them. And let me show you a dashboard which provides more insight for decision makers. Right, so here's the dashboard, and as you can see that it has different components. So here we have a heat map which shows the density of each zone. And if I play this, right, so you can see that when it is when the zone is green means that it's less dense, and when there is more crowded, there are more people, then it goes to orange and red. And here we have some statistics of the let me mention this one. So here is the zone, the previous video that you saw, and here shows the shows that the blue square that you saw that measure the people dwell time. So here is shows some statistic of the people crowd, and then we have this graph that shows the daily building traffic over months for all the zones, and this is the time series data, and we apply anomaly detection. So you can see that it's able to pick up some anomaly points. So for example, if I click on this red cycle here, it says that low traffic, and so you can see that for example, for this case, a dramatic drop has happened on a Saturday, and the system is able to predict that it is due to a camera down. But also there is another, for example, anomaly here that when you drop, you can see on another Saturday, there was a massive traffic, and so this could be due to a cruise ship arrival. On the other insights is available. For example, we integrated the sales information with the cafes and kiosks. So this shows that the daily sale that a cafe or kiosk on different zones could have. And then we get here, which shows the overall performance of each zone on this floor, and the estimated capital gains as a result of the change in metrics. Right, now let's go back to the presentation. And I'm going to show you another use case where we apply our CV technology. It's a social distancing platform for monitoring COVID-19 social distancing. First of all, congratulations again for being coronavirus free. I know that you really don't want to hear anything about social distancing anymore, as it is no longer an issue in New Zealand, but many countries are still in lockdown. And since there are no vaccines available, social distancing is the only feasible approach to fight against this pandemic, as New Zealand has proven it. So let's see how AI can help for effective social distancing to contain the outbreak. During COVID-19 lockdown, we implemented an AI-based framework for automating the task of monitoring 2-meter social distancing using surveillance video. And let's see 2 video footage where video analytics is used to monitor social distancing at the workplace. Right, so you can see that the tool is able to detect if people are maintaining the safe physical distancing over each other by analyzing real-time videos streamed from the security cameras available at the workplace. And as you can see in the video, the tool clearly identifies if people are within the safe distance, which is the 2-meter distance, or not. And here is another example. The same concept can be applied to different areas such as retail. And as you can see in this video, physical distancing analytics has been applied in the supermarket. And here, as well as the process video, this tool is able to output the structured data, which allows you to further analysis. Each row in this data contains timestamp, the ID of those people who were interacting with each other, and dwell time, the time that they spent for the interaction, and the type of the interaction. And this data can be used to build a model for predicting the social distancing alerts at a particular timestamp. Now, if you're a data scientist or you have technical knowledge to build and deploy the machine learning models, good on you, go for it. But if you are not, like 95% of the enterprises that they don't, it's going to be quite challenging. However, Fargo, our auto machine learning platform, makes it easy for enterprises to build predictive analytics models based on machine learning technology. So it takes out the complexity of building and deploying a machine learning model, and it turns it into a simple click-by-click process. You can rapidly experiment in days or even hours and get one-shot training quickly. So without a team of data science, you can easily build and deploy your machine learning predictive model. You just simply upload your structured data in a CSV format, and it firstly checks if the data is formatted correctly. And then it takes care of all the data pre-processing, which is an important and painful part of the data science, and then apply cleansing, appropriate transformation. And not even that, only that, Fargo is able to train and validate a machine learning model with minimum effort from the user and produces an output which is much more understandable for a business person. And so the output is able to explain that that what is the prediction and why the accuracy is how it is. So it makes the process much more straightforward. And Fargo is already has been applied in different use cases, and we applied that on GPS data to build a predictive model for outlier detection. Also, we apply for churn prediction for commercial video in demands providers like Netflix to understand the risk of churning. Also, we used to build an anomaly detection model on financial transaction data to figure the suspicious looking transaction. And it is already on AWS Marketplace. And yes, AI is not just for science fiction movies or for big tech companies or massive corporations. It is now accessible to all and can be used for many practical use cases. Thank you for listening. And you can take it.
Thanks, Sam. That's great. Very interesting use cases you're seeing there. And very appropriate, obviously, for the social distancing aspect side of things. Now, Brent, you've got a couple of questions for Sam?
I do, yes. There was one there about social distancing and COVID alert levels, but you covered that. A question from Vaughan. I assume that this would work for pedestrian foot traffic counts conducted by the councils. Does it need time to learn in the new environment, or could you move a camera around and get instant results?
Yes, you can, I think, take the camera and get the instant result. Like as long as, so for example, as long as you want to identify the people, then you can use it. There's no need to do any training, and can easily get adapted to the new environment.
Very good. And then there's one here from Chandra. What allowances are made to accommodate the needs of people with disabilities? For example, people who are blind and use a cane may not be aware that they are near other people.
For the social distancing use case, or?
It came in when you, oh, there we go, yes.
Okay. The thing is, even if the person has disability, still such person detection models or tracking would be able to detect them, because like the features that they so they are deep learning based models and they are quite powerful. So they are not based on just the full body. Like they can pick up as an example that I think Adam showed, that they can pick up detect a person just from the upper body, let's say. So yeah, should be fine. They might need some calibration, some to adopt the system, but in terms of detection, should be fine.
Right. Oh, sorry, she's got a follow-up question. But can they detect that they have special needs, so they might not be aware?
If they have a special need that they are not aware of.
Yeah, that might be one that Chandra might want to take up with you offline, actually. Just to clarify that. Virginia has asked one, have you looked at any applications that involve tracking objects other than people?
That's a good question. Let me recall. I think that Not really. We haven't got to any use case so far, any application. It was mainly like for sport, which and like all human, but it easily like the models which have been trained on thousand on big data set, like Coco data set, for example, for those who know. And such models are able to identify different objects, including human, including animal, including different objects. But no, like we haven't come across any projects so far to anything rather than human. But it can be easily like scale and can be easily applied.
Very good. Sagar has asked, how much training data is required or was used to train both models?
That's a good question. It's very interesting that we didn't train a model. Like we, for example, for social distancing and for retail, we use YOLO. And YOLO has been already trained on a big data set containing thousands of images, a Coco data set. And if you use such a pre-trained models, you actually don't need to train your model again. You just need just simply use them. Yeah.
Cool.
Impressive stuff. Well, thank you very much for your time telling us about some of the use cases that you've got for the technology you're developing, Samantha. I really appreciate that. You've got, you were saying to me the other day, you've got 17 data science and machine learning specialists at Arcanum, which is pretty impressive, out of the total staff and complement of around 25. So you really put the value into having the people that are doing the machine learning and data science work, and that's impressive. So clients around the country, how are people best to get in touch with you, Samantha?
Yes, like just send us email, info at my email, samantha@arcanum.ai. Or if you want to get the email of other teams, just simply go to arcanum.ai, our website.
Nice. All right, I think Neil's going to unmute everyone's microphone so we can say a quick thank you to you for your time.
Thank you. Thank you for giving me the opportunity. Thank you.
Thank you.
Thank you.
Very interesting stuff. Now, we are going to go to a last little spot of networking to wrap up our evening this evening. So one more breakout room for around 10 minutes. We'll count down and end the whole meeting at that point. We hope you've enjoyed it. Please fill out a quick survey tomorrow to let us know how you found the meeting this evening. And join us again on what I suspect is going to be Tuesday, July the 7th. The date was wrong in the notes I was given, but I updated it. Thanks, Neil. That's 4 weeks from today for our next monthly meeting, which will hopefully be a mix of real in-person interaction for those keen to attend, combined with an online component, as many have asked for these online meetings to continue. Anything?
It was a good try.
Whoever's left, the hardcore drinkers.
Bear it off.
Oh, I got to say, I missed the snacks. I'm gonna be back for the snacks next month.
And the bar service.
Yeah.
All right. Well, thank you very much, everyone, for joining us this evening. Do place your feedback tomorrow. I would love to get your thoughts on how things have gone this evening. And everything going well, we can reconvene next month physically. Let's just keep those COVID cases low and keep washing your hands and watching those little things, even though we can go out and dance in the nightclubs this weekend. Woo! Wear your mask.
Look
All
how
right.
excited
Thanks
Helen
very much,
is.
folks. We'll see you next time. Cheers all.
People. See you guys.
Yeah.